Hi, I'd like to talk to you about information integration for real-time analytics. Traditional analytics has asked questions about what's happened in the past. What happened last week? What happened yesterday? What happened in the last quarter? As we move towards operational analytics, we're asking questions to make operational decisions day by day, hour by hour. The questions we're asking are become more about what is happening now. I want to know what happened in the last hour, what happened in the last 15 minutes, so I can make decisions about what to do now, what to do in the next 15 minutes. And this move towards asking questions about what's happening now, that's what I'm calling real-time analytics. Now, I think it's useful to speak a little bit about what we mean by real time. When I first entered this industry, I worked in process control systems for hospital laundries and generation stations and things like that. They were systems that dealt with events that occurred as they occurred. So they were real-time systems. But even then, there's a constant discussion about what real-time meant. And I remember one letter to the editor I saw in one of the magazines I was reading. And it was by an engineer, and she was describing the sensor device that she had designed. And her device would be attached at one end of her meter-long rod, and at the other end of that rod would be a nuclear device, and the rod would be dropped down a hole, and the device would be detonated. And the entire operational lifetime of her device, from when it began to receive and transmit useful information to when it no longer existed, was a couple of milliseconds. And so she ended her letter saying, so I feel relatively justified in saying that I think I work in real time, but I'm sure someone will disagree. A couple of things you can take from that story. One, of course, is that I'm old because we haven't done underground nuclear testing for a long time now. The other is that the notion of real time is context sensitive. What real time means is dependent upon your environment. And so you should look at all of your analytics systems in your enterprise, all of those involved with operational analytics, and think about the questions being asked of those systems to determine how current the data needs to be to provide the best answer you can for any of those particular questions. And the scale at the bottom of this chart, I think, is a useful way to think about that. Does that analytics system need to have data that's no more than a day or two old, no more than an hour or two old, all the way up to something that's no more than a few seconds old to provide the best answer you can? And as you move towards more current data, the strategies for information integration to get the data from your source systems into the analytic system will change. Traditional load is what's been done for a long time. You take a copy of the data in the source system, you transform it, you push it into your analytics system. This is something that may have been done every week or every month. Is probably now being done every night, but still you're taking all the data from the source system and replacing all the data in the analytics system. So it's something that you will almost certainly never do more frequently than every night. Incremental load, rather than taking all the data in your source system, you're figuring out what changed since the last time you did a load and taking that chunk of data, transforming it, and pushing it into your analytics system. So it's still a batch-oriented load process, but it's something that you can do more frequently. You may do it every hour, you may do it every 10 or 15 minutes, you may do it on demand as your users decide they need new data in their analytics system. And then continuous load, that's really at the far end of this scale. You're monitoring for changes as they occur in the source system. Those changes are continuously fed through a transformation process and applied to the analytics system so that your analytics system may see changes just seconds after they were done in your source system. There are three technology patterns you might use as well as you move towards more current data in your analytics system. Infosphere Data Stage, that's an ETL tool, part of IBM's Information Governance Suite. It's designed to take large volumes of data, transform them, push them into a secondary database, an analytics database. It scales tremendously well if you have as much hardware as you can bring to bear on the problem. Data Stage can take advantage of that to move the large chunks of data as quickly as possible. Far into the scale is Infosphere Data Replication, also part of the Information Governance Suite. InfoSphere data replication is log-based change capture, so it determines what changed on your source system by looking at the database logs the database already maintains for recoverability, and those changes as they are detected are streamed through a transformation process and applied to your analytics system. And really the middle ground is using the two technologies together, using data replication to determine what changed in your system, but using the transformational power of data stage and the parallelization power of data stage to do those transformations and push that data quickly into your analytics system. So we've got three patterns. I think the next question would be, which is the right pattern for you? Things to consider when you choose the pattern are functional requirements. You've got to make sure that you're getting the appropriate currency of data so that you can be providing your business users with the best answers to their questions. And then you've got to make sure the pattern you choose can actually solve your business problem. And there'll be a few slides that talk about that following this. Non-functional requirements, minimizing impact on your source system. Often any additional load you put on your source system will actually impact the end users of that system, real business impact from that. Using data replication will always ensure you have the minimal impact that you can on that source system because of its use of log-based change capture. Of course, as well, lowering the overall cost of ownership of your solution. There's really two different aspects that can be competing as far as choice of technology patterns here. All things being equal, a solution that involved one technology is going to be simpler and cheaper to own than a solution involving two technologies. But if you have existing expertise with one of these technologies, say for example, you have traditionally used data stage, you've used traditional loads or moved into some incremental loads, you want to move into a continuous load pattern, let's say, but you have expertise doing the sorts of transformations your business requires in the context of data stage, then it may make sense to use data replication and data stage together so that you're getting the continuous load facility available through data replication and minimizing impact on your source system, but you can still rely on your existing expertise to be doing that transformations in the context of data stage. So, things to consider now looking at these patterns individually. When can you use data replication on its own? Data replication can do transformations, but it's relatively basic transformations. If you can think of each of the tables in your analytics system as being a view of one or more source tables, so it could be a join on multiple source tables, but it's really a view on just one or more source tables. That's the sort of transformations that data replication is able to do on its own. Another way to look at it, as you see in this chart, if the structure of the source data and the analytics data is the same, they're both OLTP or they're both OLAP, data replication can do that problem. But if the source is OLTP and the analytics is OLAP, that's beyond what data replication can do on its own. Flip side, what can data stage do on its own? How can you achieve low latency with data stage on its own? The simplest way for data stage to identify what changed in a database is to keep a copy of what it looked like in the past, compare that to what it looks like now, and determine what changed. But that's a relatively heavyweight process that can take a certain amount of time and a certain amount of processing. It's not something you likely would want to do every 10 minutes, even every hour. So if you want to follow an incremental load strategy where you're going to run that every hour or every 10 or 15 minutes, whatever your business requires, you'll want a better mechanism than that to identify the changes that occurred. And that's really something where you need to look at your source application, figure out how it works with the data to determine whether or not you could have that pattern. Say, for example, if it puts update timestamps on every row it touches, that's great. That's something you could leverage. Another key thing is that your source application can't do any real deletes against the data in that database. It can flag rows as being logically deleted, but it can't remove them from the database. If it removes them from the database, then the only way that data stage could determine that that row had been deleted was this heavyweight diff process that we were talking about that just isn't suitable for frequent incremental load strategy. When can you use data replication and data stage together? Well, the simple answer to that is you can always use them together. In any scenario, they can be used together. So if anytime you're going to do an incremental or continuous load, you could choose to use the two of them together. There's a range of strategies for how to use them together, how to leverage your existing expertise. That's a whole other interesting topic that will be a part of a follow-on talk.